Welcome to The Explainer. Today, we're going to try and pry open AI's infamous black box, and we're going to explore why understanding what's actually inside these systems, well, it's one of the biggest challenges in tech right now.
And this isn't some far-off hypothetical question. It was the very real problem that MIT graduate student Joy Buolamwini ran into. She was working with these cutting-edge AI systems, and they just couldn't see her face. Seriously. And her experience, it ended up exposing this huge, dangerous blind spot in the world of AI.
So to really get a grip on why transparency matters so much, we've got to look at what happens when it's not there. Because these dangers, they're not just abstract ideas, they have very real consequences for real people.
So Joy's sitting there, and she realizes these super advanced systems work, perfectly for some people. But for others, they just fail, and fail spectacularly. And this wasn't some random glitch in the system. No, it was a pattern, a really clear one. And that's when she knew she had to dig in.
And what she and her team found was staggering. It was a systematic failure. The AI was trained on data that just didn't reflect the real world. So it had this hidden bias literally baked right into its code. The result? It was way, way less accurate for darker-skinned women.
And this problem, it connects to this really powerful idea from a totally different field, intersectionality. This was pioneered by the legal scholar Kimberly Crenshaw. And her whole point is that you just can't understand something like discrimination by looking at one thing, like race, in isolation, or just gender in isolation. You absolutely have to see how they intersect.
And you know what? Emma DeGraffenreid's story from way back in the 70s, long before AI was a thing, shows this exact danger in action. She sued General Motors because, as she claimed, the company was discriminating against black women specifically.
So what happened? Well, at first, the court threw her case out. And you might be asking why. Well, GM's argument was, hey, we hire women. But they were all white women in secretarial jobs. Then they said, and we hire black people. But they were all black men working in the factory. See the problem? Black women who existed right at that intersection were completely and systematically shut out of both opportunities.
And bam, that brings us right back to AI. Because if the people building these systems are only checking for, say, gender bias, and then they separately check for racial bias, they are going to completely miss the compounded bias that hits people who live at those intersections. So the stakes are obviously super high. The big question is, how do we get a peek inside that black box before the stuff gets out into the real world?
All right, so what's the fix? Well, one of the most interesting proposals is actually surprisingly simple, and it's based on something you probably see every single day when you go to the grocery store.
Okay, so researchers, in this case at Google, came up with this idea called model cards. And you can literally think of them as nutrition labels, but for AI. The whole point is to give you clear, standardized info about what an AI model is made of, and crucially, how well it actually works.
So a model card breaks down all the important stuff. It tells you what the AI is supposed to be used for, and just as important, what it's not for. It shows you the numbers on how it performs across different groups, like age, gender, skin tone, which basically forces the creators to face any potential biases head-on. And that way, you, the user, can decide if an AI is actually a good and safe fit for what you need.
Now, what's really fascinating is that this whole idea, this need for rigorous, transparent testing, it's not new at all. Not by a long shot. In fact, it's a lesson we've had to learn, often the hard way, in a bunch of other industries. Just look at the car industry, for example. For decades, crash test dummies were all based on the average male body. And the result of that? Women were way more likely to be seriously hurt or even killed in a real crash. Why? Because the safety systems, the seatbelts, the airbags, they simply weren't designed for them. And you see the exact same pattern in medicine. For a long time, new drugs were tested almost exclusively on men. So when those drugs got approved and went to market, women started experiencing all these unexpected side effects, even overdoses. It got so bad that the FDA had to step in and mandate that all clinical trial results must be broken down by different groups.
So, look, this proves a really crucial point. This isn't just about being fair. This is a fundamental issue of safety. Being transparent and testing for everyone, that's just good engineering, period. It doesn't matter if you're building a car, developing a new medicine, or writing an algorithm.
And this whole concept isn't just stuck in academic papers anymore. Oh no, it's quickly becoming a global standard for policy, getting baked right into major international agreements. Take the OECD.
the Organization for Economic Cooperation and Development. We're talking about an organization of 38 countries here. They saw this coming, and they created the very first intergovernmental standard for how we should be building and using AI. And if you look at their principles for trustworthy AI, what do you see? They're explicitly calling for transparency, explainability, fairness, and accountability. This basically creates a global starting point, a baseline that pushes companies and governments to work together and make sure these powerful systems are built and used the right way.
Okay, but let's be real. A framework is only as good as the people who actually use it. And that leads us to a really, really big question. When an AI messes up, who's on the hook? Who's actually responsible?
To really wrap our heads around this, let's use a little thought experiment from the book Responsible AI. So picture this, Robbie the robot. It's a nanny robot designed to take care of kids. Now, what if Robbie makes a mistake? A serious one. Who's at fault? Is it the person who wrote the code? The company that sold it? The parents who bought it? Well, the answer is it's kind of everyone. Responsibility isn't just one person's problem, it's shared across the entire chain. The company's board has to manage the risks. The data scientist has to make sure the training data is fair. The government needs to create the rules of the road. And even us, the general public, we have a role to play by giving feedback on how this stuff works in the real world.
You see, there's no single magic fix here. Building AI we can actually trust takes a whole combination of things. You need smart documentation, like those model cards. You need strong principles, like the ones from the OECD. And maybe most importantly, you need a culture where everyone feels a sense of shared responsibility, all the way from the boardroom down to your living room.
And that leaves us with one last, really critical question. We are building these incredibly powerful AI systems, but are we building the trust to match? Because the real challenge isn't just making AI that works, it's making AI that works for everyone. An AI that we can all collectively trust. The tech is moving at lightning speed. The essential work now is making sure our ability to trust it can actually keep up.